Jacob, and Matthew. Dr. D told us we needed to learn more about the scientific method. It might help us solve the problem of stink invading the town of Fuseville. We were hoping you could help us. Wow, look at this place. Hey, this doesn't look like a lab. This looks like a plane.
Are you a scientist?
Well, not exactly. Let me ask you something. Have you ever heard of an engineer?
An engineer? Isn't that someone that drives a train, designs, or invents something?
That's correct, on all accounts. I'm an electronics engineer, and we use math, science, and principles of electronics in order to help us with our flying laboratory.
A flying laboratory? What do you mean by that?
Come on, kids. Let me show you how it works. Our plane is more like a computer lab with lots of electronic equipment and aircraft systems. And here we even have a real cockpit, just like normal planes.
I'd like to be a pilot one day.
And I'm sure you will. Well, maybe you'll fly this plane.
Cool.
We have several experimental stations in our plane which are all tied together in a network. They work together to help us to collect data while we're flying and landing. The type of data we collect depends on the type of research we're conducting. Get it?
Yes, but how do you use the scientific method on your job?
Well, the first thing we do using the scientific method is to identify a problem, right?
Right.
Well, the second thing we do in using the scientific method is to collect data related to the problem by changing certain variables.
What are variables?
Well, variables are just changes. We change one or more things, one at a time, and then we measure the results of that change.
How are you going to do that?
During the winter season, we are going to take the airplane to a very cold place, like up in Michigan near the Great Lakes, and land it on a very long runway. Then we'll test the plane by landing it on a runway to see how long it takes once the brakes are applied to stop the plane. This tells us how much friction that we have on the tires. It's just like taking your bicycle and trying to stop on ice or snow instead of on a dry, smooth road. So we'll test at least 4 variables in our experiment: a dry surface, wet surface, icy surface, and a snowy surface. Let me show you how we can look at some of our data. We can observe all of the different camera views at the video station. These computer-generated graphic displays help us see how the airplane is traveling down the runway.
Wow, cool pictures!
It can handle millions of bytes of data all at once. This represents the data collection part of the scientific method, and the results come out in a pattern of numbers that the researchers can use to tell how the tires reacted with the runway surface.
Awesome! What do we do next?
Next, we take the data that we collected and we analyze it in order to help us solve our runway friction problem. We can use what we find from analyzing the data to make better runways and landing gear to help our planes to land more safely during bad or inclement weather. This is the way that we help make our airplanes and airports safer for you and me. So this is how we use the scientific method on our Boeing 757 research laboratory out here at the NASA Langley Research Center. Now that we've shown you how to first identify a problem, next to collect the data by changing certain variables, maybe you can use this method in order to solve your problem with the stink.
Yes, I think we should think about our variables for the investigation of stink. The stink!
And variables.